Okay, this video is going to look at tree diagrams, and this video assumes that we've already looked at probability in two-way tables or arrays. Basically this goes from the same purpose. Tree diagrams are used again to list the sample space for experiments. They're for two steps, like in the two-way tables that I assumed you've looked at before, but they can go more than two stages or for more than two steps. That's an advantage of them. The outcomes for each stage of the experiment is listed vertically, so you need to work nice and neatly and vertically, and we have branches to connect everything, so make sure you've got a definition for that. You can see two examples below. So the first example I'm going to highlight in green, and this one is tossing a coin 3 times, so that means there's 3 steps or 3 stages. Now we can see the 3 stages or 3 steps by looking at the vertical alignment. That's step 1 or stage 1. So you always start at the beginning of a branch and then it branches out. In this case there's 2 alternatives on the first time you've tossed the coin, so that's the first stage, and it could be head or tail. And in the second stage you can see the outcomes are there, and this is 3 times, so the third stage is written here. Let's read this through, see if we can make sense. So on the first toss of the coin we can get a head or a tail. Now if we look at this head here, given that it's a head on the first, on the second it could be a head or a tail. And on the if alternatively we got a tail on the first toss of the coin, the second toss could come out as a head or a tail. Okay. Beyond that, what can we have? Well, if we've had a head on the first and a head on the second and we're ready for the third one, we can get a head or a tail on the fourth one. So on the third one, sorry. So again, this one would be head on the first, head on the second, and head on the third. And we would call that HHH. You should list the outcomes at the end like this. Notice how everything is neat and vertical. Be careful when you draw them that you have enough space, because they get very tall. You need enough space across, and you need enough space up and down when you set these out on your paper. I'll do one more example here. Let's say we got a tail on the first, and then we got a head on the second, then we've got a tail on the third. That would go along that path there. We would call that tail, head, tail. And this one we've got 1, 2, 3, 4, 5, 6, 7, 8 different outcomes, and they are all equally likely. The next one we've got here is a different case. I'll highlight it in yellow. This is selecting 2 letters, maybe from a bag that's got balls on it, with A, B and C on each of the ping pong balls. Okay, and this would be choosing at random. Now this one is without replacement, so we've got on the first trial we could choose an A, a B or a C. Let's say we choose an A on the first one. On the second one we could choose a B or a C. Notice how there's no A because it's without replacement, so we would call that branch AB. Likewise, if you get a B on the first, you can only get an A or C on the second, and likewise for C. So that's how you do a tree diagram for with replacement and without. Very important point is that in experiments like this one, the outcomes at the end, all of these things, are all equally likely with this sort of system. Same with these are all equally likely to each other. In further probability, you'll learn probably next year, this isn't always the case, but in the ones we're going to do at this stage, all of these outcomes at the end are equally likely, which makes life a bit more easy. Quick examples. An experiment involves tossing 2 coins and complete a tree diagram. So we start by drawing on the first toss, we can get heads or tails, we just go H or T. Alright, now we're tossing coin 1, and if coin 1 is a head, we can look at the outcomes for coin 2. So you put your second step or your second stage, which is coin 2. If coin 1 is heads, coin 2 could be heads or tails. If coin 1 was tails, coin 2 could be heads or tails. And at the end we just write down what the outcomes are. So the first one is HH, second outcome is HT, TH, TT. What is the number of outcomes? 1, 2, 3, 4. So there are 4 outcomes. Part C, we've got what is the probability of tossing 2 tails. Now all of these outcomes here are all equally likely, as we said. 2 tails, there's only one outcome there that fits 2 tails, is that. That's one outcome out of 4 that are equally likely. So the probability of 2 tails equals, put it on the next line, is 1 out of 4. Probability of 1 tail. Well, the order's not important, it just says 1 tail, doesn't say first or second. There's 1 tail and there's 1 tail, that's 2. 2 out of 4, so the probability of 1 tail is 2 out of 4. We can simplify that to a half. And at least 1 head, at least. Now that means 1 or 2, 1 head, sorry, it's a H, or 2. Okay, so let's look at all of the ones that fit into that, and I'll go to yellow. So 1 head or 2. Okay, that's got 2 heads. Yep, there's 1 there that's got a head. 2, 3. The green one there is not. So that's 3 out of 4. So the probability is 3/4. So that's the probability of at least 1 head. So greater than or 1 head. We'll put that there, and that was 3 out of 4. Okay, and that will do for this video. There'll be a second part next time.